Very well. In this second part of this course, we're going to see organized data and how we can use the different packages like tidyr and dplyr to uh, organize data and to keep that data organized, because this format is what's most appropriate in order to run analysis and to prepare the graphs and to show the results. And as a definition of the organized data, we have every variable must have its own column. As you can see here, every variable has its own column, and each observation must have its own row. So I have an observation in each one of the rows, and each value must have its own cell. So the combination of observations and variables would be in the values of each one of the cells. And it appears to be very simple, but due to different reasons, many times this format, which is very practical for doing analysis and to create graphs, is not the best one to collect data or to store data at a long term. So many times when we do this, the data is not there. So we need to have functions to change between formats in order to have data that's properly organized. And one of those functions is called pivot longer, and this generates these wide and long formats. For example, if I have this format over here, which is a wide format, and I use the function called pivot longer, what's going to happen is this: things are going to separate in several parts, and they're going to be joined in this way. The rows are going to be organized this way. So in the end, I'm going to have this set of data that's in long format. And this format, generally speaking, does not mean that the data is going to be in the organized format. So it depends on how the data was initially collected and how I'm going to separate them to reach that point. This is an example of how we could apply this function in this set of data that we've been working on. So I have a set of data from the crop, but it's in a wide format. And I have two different columns here, one for irrigation or riego, and the other one's temporal, temporary. So I have the values for yield in both columns. And this can be very useful to do a comparison, for example. And I can have a table where I can see that the yield for irrigation is higher. But in order to create graphs and to do analysis, I'll probably need for the data to be in a more in a longer format. So I can use the pivot longer function to do that, and I can change the data for doing that. So I have the mode of production in one column, and the observations are here. So this is the organized format that's going to make it a lot easier to carry out analysis. And the opposed situation would be when I already have data that's very long and I need to pivot wider. So I used a function pivot wider that's going to generate those um, wide and short tables. So I have cases in which I have the number of cases in the population. All of them are here in this column and the type column. So the values that I have in this column are not an only variable, but this would be two variables. So I can change it in order to have a data that's more organized. For example, when I have cases in a population in each one of the columns, and it's going to facilitate the analysis process. And also, we also have the example with our data. I have long data here, the ones that I showed before, but at this time I have a variable like area and yield. Both of them are here as variables, and these are my values. So for example, if I want to take an average from this column, it won't make any sense because I have two different sizes here. So what I'm going to do is to use a pivot wider, and I have the area in a column and the yield in another column. So if I want to see what was the total production, I can have the product here of the area and the yield, and everything is a lot easier with this format. In this way, it's going to be easier to use these functions to change one format from one format to another, and it's going to be easier to carry out any analysis and present the data.